This is lesson 5.4, Compound Inequalities. Compound inequalities can have the word and or mean the word and this could be written in one of the two following ways. It could say, as in the blue here, x is greater than or equal to 3 and x is less than 7, or it can be combined together, as in the green, and read 3 is less than or equal to x and x is less than 7. So 3 less than or equal to x less than 7. So you'll see two inequality symbols when it's a compound inequality, and for the word and, it'll either have the word and or it'll have no words and have the two symbols. When we graph, we're looking for an overlap between the two parts of the compound inequality, and only the overlapping areas go on the graph, and that is your solution area. Alright, the first example here at the top, -2 is less than or equal to x minus 3, which is less than 4. The first thing I want you to do is to separate this into two separate inequalities. So as you start to read, you read -2 is less than or equal to x minus 3, and you stop here before you get to the other sign. So let's write that separate. -2 is less than or equal to x minus 3. And we know it's the word and because there's two symbols and no words. So we'll put the word and next. Then when we read the second part, we start behind the first symbol and read the stuff in the middle, the x minus 3 less than 4. So x minus 3 less than 4. Notice all of this stuff that's between the two symbols is repeated in both of our separate situations. Now from here we're going to solve both. So as we're reading the first one and solving, we look at x, we'll add 3 to both sides. -2 plus 3, that will give me 1 is less than or equal to x. Still have the word and then over here we'll add 3 and I'll get x less than 7. Now as I go to graph this, I need to do a little thinking, so I'm going to do my thinking above the number line, and then I'll bring my solution down to the number line. So let me number the graph that I have here. I think I can start with 0 and work my way forward here. So if I were going to graph x is less than or equal to 1, that would be a closed circle at 1. So way up here above the 1, I'm going to put a closed circle. Now 1 is less than or equal to x, so that means it would shade to the right if I were just graphing that part. Then if I look over here at x is less than 7, that would be an open circle at 7 going to the left if we were graphing just that part. So there's my thinking of the two parts. What I'm looking for is where do they overlap. So I can see starting right here at the closed circle and going over here to the open circle that they overlap between. So what I'm going to bring down for my solution is the closed circle here at 1, and I'm going to bring the open circle for the 7, and then I'm going to shade in between, and make your shading where there's no doubt we can tell where your shading is located, because that is the solution area. Only those values will work. 7 does not work because it has an open circle, but 1 would, and then all the way up 2, but not including 7. Alright, we'll go quickly through a couple more. On this one it has the word and, so I just need to solve. So I'm going to subtract 3 from both sides. N is greater than or equal to 2. And then over here I'm going to go ahead and bring my word and down. I'm going to add 1 to both sides and have n is greater than or equal to 7. So I'm going to count down here 0, 1, 2, and get my number line numbered. I'm going to think up above for n greater than or equal to 2. That would be a closed circle here at 2 going to the right. For n greater than or equal to 7, it would be a closed circle at 7 going to the right. And since we're looking for an area that overlaps, we're going to start right here where this second closed circle was, and then it continues to overlap all the way out. So we'll bring down the closed circle at 7, and then we'll shade to the right, and that will be our solution area. 7 and anything bigger. If you get the situation where there is no overlap, then there's no solution, and you leave your number line blank. You draw the number line, you can number it, but do not do any circles or any graphing on that number line. If there's no solution, write no solution and leave the number line blank. The other possibility when you're doing compound inequalities is working with the word or. So when we're looking for all the possible solutions from both parts of the compound inequality, then we're going to use the word or. So we call this the union of the graphs because we're going to bring down every possibility from either side. Sometimes they'll overlap, sometimes they won't. Let's look at a few. So in the first one here, we're going to solve. So quickly to solve, we'll subtract 1, so x will be greater than 2. Notice we have the word or now. We'll subtract 2 from the other part over here, and we'll have x is less than or equal to -1. So again, as we're kind of numbering our number line down here, we'll do our thinking up above. I'm going to get a number part way this time. If we did the greater than 2, it would be an open circle at 2 going to the right. If we do the less than or equal to -1, it'll be a closed circle at -1 going to the left. There's no overlap, but with the word and, that doesn't matter. So what I'm going to do is bring both parts down because I want to include all those possibilities because either or works. So bring down the closed circle and go to the left. Bring down that open circle and go to the right. And there's your solutions. All right, on the next one, as we're graphing, I'm going to subtract 7 first, so I'll have 2m is less than or equal to 6. And then I'm going to divide by -2. And remember, when you divide by negative numbers, you got to flip your inequality over. And then we'll have m is greater than or equal to -3. Bring down your or, because that's going to tell you how the graph's going to look. On the other side, I'm first going to subtract 12, so I'll have 5m is greater than 25. Then divide by 5, m will be greater than 5. Right? Again, as I'm going to my number line, above it at m is greater than or equal to -3. So up above -3, I'm going to draw a closed circle. That would shade to the right if I were just graphing that part. And then as I'm going over here, m is greater than 5. What I'm going to do is a close or an open circle at 5, and that's also going to go to the right. So notice that we've got an overlapping area, but because it's the word or, we have to start out here so we don't forget all these possibilities up to the overlap. So we'll bring down the closed circle and we'll shade all the way over to the right. We don't bring down the open circle because that first line, that top line, would cover in that circle because that becomes a possibility for m greater than or equal to -3. All right, and then we'll solve this one quickly. We'll have n is greater than, if we subtract 3 from 1, we'll have -2. Or we'll have, if we subtract 2 from 5, we'd have n is less than 3. So again, as we start to number our number line, wherever we can get the -2. We'll say -2 is this first line here. So we'll have greater than -2 going this direction, less than 3, if that's -2, this would be 3 right here. It would be an open circle going this way. Now they go opposite directions in overlap, so they're going to cover all possibilities, going to cover the entire number line. So you actually shade the entire number line, no circles here, and then we state that our solution is all reals because every number will solve one side or the other of our compound inequality. All right, for more review, you can look in your textbook and follow that, or you can go back through the video. For homework, work on pages 306 and 307. Do numbers 2 through 32, evens only.